Good morning. So far we have seen the different topics of the first unit, that is the basic building blocks of FPGA and two types of FPGA boards and the VHDL language programming style, that too entity representation and different types of architecture body representations. Now coming to another unit, that is VHDL data types and operators as a heading. So in this we can cover the basic elements of the language mainly. Okay. What are the basic elements here are identifiers, data objects, data types and operators. These four are considered as the basic elements of the VHDL language. Identifiers, data objects, data types, operators. So coming to identifier, so what is identifier means? The group of characters which is used to name the entities, architectures, signals, constants, whatever. So wherever the user can define his own name for different modules or parts or signals or objects, then you can use the identifier. Okay, usually how can you define is identifier? Identifier is a sequence of characters or group of characters. Okay, and the characters may include the alphabetic letters A to Z, the digits 0 to 9, and from the special characters only underscore is used. Okay, characters, as a character we can use the letters A to Z, either small or capital, both are treated as same because the language is a case insensitive language. Digits 0 to 9 and the special character underscore. Okay, only these characters are used in the identifier. Okay, the purpose of identifier is which is used to name the entities, architectures, procedures, functions, signals, etc. Okay, and while giving the name you need to follow certain rules. Okay, the rules are the identifier should start with alphabetic letter only. Okay, the starting letter or the starting character must be a letter. And must not end with the underscore. And two successive underscores you should not use. Keywords, reserved words are also not used. Okay, space also not used. So these are the certain rules you have to follow while giving the name. Okay, so that is about the identifier. So for example, let us see an example. In case of entity, in previous sessions we declared entity declarations, architecture declarations for half adder, full adder, like that. Okay, suppose so if I want to write an entity for a 2 by 1 mux, 2 by 1 multiplexer. Okay, for the 2 by 1 multiplexer, how many inputs it has? 2 data inputs, 1 select input and 1 output. Okay, multiplexer you can define as 2 power n by 1, where 2 power n is the number of inputs, n is the number of select lines and only 1 output. Like that a multiplexer we can define. So in this example I am taking 2 by 1 multiplexer. So let us see where identifier is used. So entity followed by entity name. Okay, entity name, what is entity name? It is user defined name. User can write his own name. Okay, whatever the name he like or she like, that name he or she has to place. Okay, here I used mux. Okay, so this is the identifier. So mux is the identifier. Okay, is then port of A, B, S, A comma B comma S. These three are the multiplexer inputs. A is one signal, data signal, B is another data signal, S is the select input. Select input. A is data input, B is also data input, S is the select input. Okay. The names of these input signals also defined by the user. So this is also identified. Then coming to output. Output port name is Y. Okay, output port name is Y. So that is also identified. Okay, so like that, wherever the user defined name is there, that is identifier. Okay, identifier is used as a user defined name. Okay, similarly, if you see in half adder case, entity half adder, see here half adder. Okay, so since space is not allowed between half and adder, instead of that an underscore is used. Okay, so like that, the identifier is helpful to name the different units like this. Okay, is it clear? So that is about the identifier. Okay, next coming to another element is data object. Data object. So what is data object means? The data objects are used to hold the specified type of data. Data object is used to hold or to save the specified type of data. Okay, specified type of data. But in the language there are 4 classes of data objects. Those are constants, signals, variables and files. Okay, so these are the 4 categories of data objects we have: constant data object, variable data object, signal data object and file data object. Okay, so whatever the data object, their purpose is to hold or to save the specified type of data. Okay, specified data type of data. Okay, first of all, coming to constant. How the constant is declared? First of all, let us see how a constant is declared. Okay, and what is the function of this constant means? Of course, it holds the data, but the holding data is fixed. Whatever the initially placed data in the constant, that is fixed always. During runtime, it may not change. During runtime or during simulation time, the value of the constant object may not be changed. That is the meaning. Okay, now coming to syntax of this constant, that is how can you declare a constant in the language. So that is constant, which start with the word constant followed by constant name. Constant name is the user defined name. Constant name is user defined name colon, then type name. Type name is data type. Data type, type name, then colon equal value. So and finally, you know, every declaration or every statement ended with the semicolon. Okay, so the syntax is constant name colon type name colon equal value. Okay, that is whatever the name you enter at the constant name, that name is considered as constant object. Type name represents what type of data that constant objects can be hold. Okay, then suppose if you want to assign a value initially at the declaration itself, you can use colon equal value. That is the assignment symbol. Colon equal is the assignment symbol in the declaration case. Okay, so for example, if you see here, we have the 2 examples. One is the constant rise time colon equal 10 nanoseconds. It means rise time is an object of constant type, it holds time type of data, it holds time related data with value 10 nanoseconds. Okay, So time type of data with the initial value is 10 nanoseconds. Okay. So with the value of 10 nanoseconds. Okay. Similarly, another constant declaration you can see here, that is bus width. Bus width is another object, so which holds integer type of data, initial value here is 8. Okay, so like that, a constant declaration and assigning the initial value to that object can be observed here. Okay, so that is about the constant. Then coming to another data object is, that is variable. Okay, so variable is the name itself represents whatever the value the variable consists, the variable object consists. It can be changed during the simulation time or run time. It is not fixed. That is the meaning of the variable object. Okay, so the variable object value can be changed. Okay, the variable object value can be changed during the simulation time, may or may not. Okay, that depends on the programming technique. Okay, so but how and what is the syntax for the variable declaration is similar to constant declaration. It is also starts with the word variable, then variable name colon type, data type. Okay, variable type is data type, that means then colon equal initial value, but colon equal initial value is it is optional in case of declaration. Okay, you can assign the value in the declaration itself, or during runtime or during simulation time you can add the value, or you can save the value in the variable object. Okay, so this is the syntax. Syntax is similar to constant declaration. Now see an example for this variable declarations. It starts with the word variable, then found comma done colon boolean. So what does it mean? Found is one data object. Similarly, done also one variable type of data object. Both can hold which type of data? Boolean type of data. Okay, Boolean type of data. So what is meant by Boolean type of data means? So Boolean is a predefined data type. Okay, predefined data type. It consists only two values. Those are true and false. So since found and done objects are declared under data type Boolean, they can accept either true value or false value. The word true or false, like that. See, the second example is variable. So variable sum colon integer range 0 to 100 colon equal 10. That means sum is an object of type variable. It holds integer type of data. It means it holds integer type of data. That too, the acceptable integer range is 0 to 100 only. And initially we are assigning the sum with the value of 10. Okay, so like that you can generate. Similarly, another model is variable control status colon bit vector of 10 down to 0. That means control status also an object of type variable. Its data type is binary. Bit vector means the vector notation is used when you want to assign more than one bit. Okay, bit vector. It accepts either zeros or ones, more than one bit. But how many? 10 down to 0 means 11 bits. 11 bits the control status can accept. Okay, so that is the meaning of the bit vector of 10 down to 0. So like that, the variable is declared and its uses in the, its declaration and uses in the VHDL programs. Okay, so now I am stopping this session. In the next class you can see another data object declarations and also rest of the topics. Okay, thank you.